Hello and welcome back. Today we're doing 7th grade math, chapter 1, lesson 5. We are dealing with graphing proportional relationships. So we have a whole lot of vocab here. Coordinate plane, quadrants, ordered pair, x-coordinate, y-coordinate, y-axis, origin, and x-axis, most of which we have done during our 6th grade year. So let's go ahead and let's use this time to show our graph. So again, a graph is made up of two lines. The two lines are the x-axis and the y-axis. Now, we have sections that are called quadrants. Quadrants are based on an ordered pair. So again, an ordered pair are two sets of numbers like 1 and 2. 1 is our x-coordinate, and 2 would be our y-coordinate. It's always x and y. X tells us to go left or right. We go right if it's positive, left if it's negative, and if it's 0, we stay there. And then y will go up and down. Up if it's positive, down if it's negative, and we stay at the same place if it is 0. So, quadrants are set up as follows. We go counterclockwise. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant 1 is going to be positive, positive. Quadrant 2 will be negative, positive. Quadrant 3 will be negative, negative. And quadrant 4 will be positive, negative. So again, that represents what the ordered pair would be. So for example, 3, negative 2 would be in quadrant 4 because we'd go 3 to the right and then 2 down, which would be 3, negative 2. Now remember, if a ordered pair has 0 in it, it's going to be the opposite number or the opposite coordinate. So if it's 0 is in the x-coordinate, 0 tells us not to go left or right. Y tells us to go up 2, we'd be right here. So this point would be on the y-axis. It would not be in a quadrant. It would be on the y-axis between quadrants 1 and 2. All right, continuing on. So it's going to go ahead and undo that. So I think we've covered most of our vocab here. Let's see. We've covered coordinate plane. So again, coordinate plane is all of this entire graph. Quadrants we've talked about, quadrant 1, 2, 3, and 4, starting from the top right and going counterclockwise. So again, top right going this way will be 1, 2, 3, and 4. And we've talked about what the ordered pairs are. We've talked about x-coordinate, y-coordinate. Again, the first number in an ordered pair is x. The second number is y. X tells us to go left or right. Y tells us to go up or down. We've talked about y-axis, x-axis, and then the origin. Origin is the spot right in the middle between all of them, and that origin is known as 0, 0. That is the coordinate. That is like your front door. That is where you start your journey. You start at the origin, and then you start moving left and right, and then up and down depending on your ordered pair. So very important that we have this as a refresher in our notes. So again, how to tell if it's proportional on a graph. Ask the two questions. Does it go through the origin? Yes or no. And is it a straight line? Yes or no. So we're going to go ahead and look at our lesson here before we get into our notes again. So maps have grids to locate cities. The coordinate plane is a type of grid that is formed when two number lines intersect at their 0 points. The number lines separate the coordinate plane into 4 regions called quadrants. So this, again, is the coordinate plane. An ordered pair is a pair of numbers such as 1 and 2 to locate the graph. So again, x-coordinate, y-coordinate. This would be in quadrant 1. Graph points to 3. 2, 3 would be, we start at 0, 0, 2 to the right, 3 up, we'd be in quadrant 1. -3, -2, we'd be -3 down, -2, we'd be in quadrant 3. And then connect the 3 points on the coordinate. So it'd be up there, down here. Let's see. Identify proportional relationships. Another way to determine whether two quantities are proportional is to graph the quantities on the coordinate plane. If the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. The slowest mammal on Earth is a tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of the minutes it moves by graphing on the coordinate plane. Explain your reasoning. Sorry for the pause. So basically, this table here, and let me see if I can draw on OneNote really quickly. Let's see if it'll let me draw. It does. This table here is our ordered pair. The top number will be our x, the bottom number will be y. So we're going to start at 0, 0. Notice we already are starting in the origin, which is good because if no time passes, the sloth's not moving. So it's 0, 0. After 1 minute, our sloth has moved 6 feet. Sloth moves at the rate of 6 feet per minute. So we'd go from here at 0, 0, go over 1 and up 6. Now, this only goes up by 4, so we have to kind of guesstimate where it's going to be. It's not quite half, but it's over there. Next one, 2 minutes, he'll move 12 feet. So we go 2 to 12. Boom. 3 minutes, 3 minutes, 18 feet. 3, graph up to 18, right there again between the two. And then in 4 minutes, 24 feet, and so on. Notice there is a constant relationship here. 1/6 is equal to 2/12. If I divide 2/12 by 2, it will equal 1/6. Same thing with 3/8. If I divide this by 3, it will go back to 1/6. So there is a relationship here, and all of these are proportional. And you'll notice that when I graph it, it goes through 0, 0, and it'll go in a straight line. This is a good way to tell if they are proportional or not. It will cross through the origin point, and it will start a straight line. If it does not start a straight line and go through the origin point, these are not proportional. So let's do this problem to find out. James earns, and we're going to go ahead and zoom this in, and it may be a little blurry, but it's fine. James earns $5 an hour babysitting. Determine whether the amount of money James earns by babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane. Explain your reasoning in the work zone. He earns $5 an hour babysitting. There is no base pay. There is no bonus for certain hours. So every hour he works, he will earn $5. So we start at 0, 0 because if he doesn't work, he doesn't get paid. So 0 hours spent means $0 made. We're going to go ahead and see if we can get this to be a little bit. There we go. That's too big. That should be right about enough. So 0, 0. We'll change the color here so we can see it on the graph. We'll do light blue. 0, 0 will be right there at the origin. He's not going to make any money if he's not working. So if he works 1 hour, he's going to make $5, and it'll be right between 4 and 6 here. So that's where we'd graph 1 hour. 2 hours, $10, so he'd be right there. 3 hours, $15, and he'd be right here. And then 4 hours, $20, which would be like off on the graph somewhere. But we're going to ignore that 4 hours. Notice when I graph it, it's going to be in one straight line, and it does go through the origin. Therefore, these are proportional. And we'd write a little sentence saying, yes, these are proportional. Explain your reasoning, because every 5 hours, or every 1 hour, he'll earn another $5 for babysitting. So it is proportional. The cost of renting video games from Games Inc. is shown at the table. Inc. stands for Incorporated. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane. Explain your reasoning. So, we're going to start off with one game costs $3. Two games cost $5. And you're going to notice right off the bat, they're not proportional because if every game cost $3, two games would have cost $6. There's a little bit of a discrepancy here. So there's a little bit of a discount. The more games you rent, the lower it costs. 3 games equals $7 instead of it being $9 because if one game costs 3 games should cost 9. And then 4 games will actually cost $9. So right off the bat, just by looking at these, this is not proportional. Proportional would be that every game that you rent would be $3, meaning this would be 6, this would be 9, this would be 12. And they're not, therefore, not proportional. This is not a constant rate. Write two quantities as ordered pairs, number of games and cost. The ordered pairs are 1 and 3. So we're going to graph this and we're going to see that it's not going to be a straight line. So I'm going to make this a little bit smaller. We're going to get our dot back. So graph the ordered pairs. So I have 1, 3, which is right here. Then we have 2, 5. Oh, sorry. 2, 5 is right here. 3, 7 is right there. And 4, 9 is right here. Notice when I draw the line, it is a straight line, but does it go through 0? It does not. It does not go through 0. And I'll erase this really quickly so we can see their work. Again, it won't, because if we look at our question again, the cost of renting a video game from GamesInc is in the table. Determine the cost. So one game costs $3, 1, 3. I don't know why that dot's there, but as we go through, because renting no game shouldn't cost $1, but as you see, our line does not go through. Now, if it were, let's go ahead and look at this. If each game were $3, 1 to 3, 2 to 6, 3 to 9, 4 to 12, our graph would go in a straight line and it would go through 0, 0. In this case, our graph does not go in a straight line and does not go through 0, 0. Or sorry, it does go in a straight line, but it does not go through 0, 0. Therefore, this is not proportional. All right, let's review our notes. So again, example proportional here was yes. This was the $5 an hour question. This one is no, not proportional, because this is the one video game costs $3 question. And then this one kind of just bent up a little bit, and we're going to go ahead and do that one right now to show you guys how that works. So, the table shows the number of calories an athlete burned per minute of exercise. Determine whether the number of calories burned is proportional to, so after 0 minutes, they burned 0 calories. So we're right here. 1, they did 4. 2, they did 8. 3, they did 13. So you're going to notice we're not going to have a straight line here. We're actually going to have a little bit of a curved line. It's going to curve. No, it's not a deep curve, but it is a curve, meaning it's not a straight line. These numbers will start bending up as we go along. So this will not be proportional. Because again, even though it does go through 0, 0, it won't be proportional because it's not a straight line. It must be a straight line going through. So going back to our notes over here, not proportional because it is not a straight line. It is curving. So again, for it to be proportional, it needs to go through the origin, which this one did, but it needs to be a straight line, which this one is not. This one was a straight line, but did not go through the origin, therefore not proportional. This one was a straight line and did go through the origin, therefore it is proportional. All right, we're going to go ahead and do a homework question on this one. So you've got coordinate planes here, and you've got coordinate planes again. And we're going to look at our homework. So let's do question 1 together. Determine whether the relationship between the two quantities shown in each table are proportional by graphing on the coordinate plane. Now, I know some of us can already look at this and tell, yeah, 1 and 1, 2 and 8, 3 and 27, not proportional. But let's go ahead and graph it anyway because it's asking us to graph it. So 1 to 1. And that would be somewhere right here because there is no 1 here. 2 to 8 would be somewhere around here. 3 to 27 would be up here. Notice not going to be a straight line. There's no way. If I draw a straight line through here, I'm not meeting that 3. So not a straight line. So automatically we know this curves, and it automatically does not go through 0, 0. So not proportional. And if we look at our answers here for number 1, ooh, I'm on the wrong thing. Number 1 is not proportional. All right, and that's it for lesson 5. As always, questions, comments, concerns, you guys know where to direct those. You have questions in class, please make sure you raise your hand and you ask. As always, this is Mr. P signing off.